In this video, we are going to see the combination and the lifetime of batteries. Batteries can be combined in three ways: in series, in parallel, or in opposite directions. In series, in this type of combination, positive end of battery is connected to the negative end of the other battery. You see here that you combine with positive negative. This negative is combined with the positive end of the other battery. Negative, positive, negative, positive, negative. This combination in series, you see that the positive end is combined to negative end, positive end is combined to negative end. You see here that we have a number of batteries connected in series. So the total electromotor force of the batteries will be equal to the sum of each battery, how many you have added. Here I have identical batteries, so the total electromotor force is equal to N times E. And also here the batteries have internal resistors, so think of them as normal resistors. They're in series, so the total resistance in the circuit will be equal to the sum of the resistance of the batteries plus the resistor in the circuit. If the batteries are combined in opposite directions, what we mean, you see here that positive, negative, negative, positive, then they are combined in opposite directions. So in finding the total electromotor force, we are going to subtract them. In the first example, let's say E1 is bigger than E2. So the total electromotor force will be equal to E1 minus E2. So the current passing from the circuit will be in this direction because E1 is bigger. It is equal to the total electromotor force over the total resistance in the circuit. In the second one, let's say E2 is bigger than E1, so the total electromotor force will be equal to E2 minus E1. So as E2 is bigger than, the current will be in this direction, which is equal to E2 minus E1 over the total resistance and R times R. If they are equal to each other, then the total total electromotor force will be equal to 0, so there will be no current in the circuit. Let's do an example. The given circuit, we have the batteries with the values of 1.5 and the reading on the ammeter is asked. Now let's find the combinations plus minus, plus minus, plus minus. So there's no opposite combination. So the total electromotor force is equal to 4.5 volt. They have the internal resistance as 3 and a normal resistance 9. So the total resistance will be equal to 3 plus 3 plus 3 plus 9, which is equal to 18 ohm. So the current passing from the main circuit from voltage over resistance, which is equal to 4.5 over 18, 1 over 4 ampere. The second type of combination is the batteries in parallel. In this type of circuits, batteries must be identical, and we line the batteries as positive ends at one line and the negative ends at the other line. All of the batteries should be between the same potential difference as in the examples. They are all between the potentials AB. Now here we have a number of batteries connected in parallel. No matter what the number of batteries is, the total electromotor force or the voltage is equal to the voltage of one single battery. If they have internal resistance, then we combine it as 1R equivalent is equal to 1 over R times 1 over R. How many you have? So here I have n number of resistors, so the total of the resistance of the batteries will be equal to R over N. So I have a resistor here, so the total resistance is equal to R plus R over N. So the current passing from the main circuit will be equal to E over R plus R over N. In this example, these two batteries are combined in parallel, so the total voltage will be equal to again 1.5. They are combined in series, so I'm going to add them. 4.5 plus 1.5, which is equal to 6 volt. Now let's come to the resistances. 2 and 2 in parallel, so I add and find by 1. 1 and 3 and 6, they are all in series, so the total resistance will be equal to 1 plus 3 plus 8, which is equal to 12 ohm. So the current passing from the main circuit from the Ohm's law, 6 over 12, which is equal to 0.5 ampere. The lifetime of battery is inversely proportional to the current taken from the battery. The more current taken from the battery, the less the lifetime of the battery is. So first, let's find the current passing from the main circuit and then calculate the current passing from the battery. The total voltage is equal to again 12 volt. So here, let's say I1 is equal to from V over R 12 over 6, which is equal to 2 ampere. 2 ampere pass from here, so 1 ampere come from the first battery and the second one come from the second battery. So the current I have taken from the battery is equal to 1 ampere. In the second one, they are connected in series. The total voltage is equal to 24 volt. The current taken from the main circuit is equal to 24 over 6, which is equal to 4 ampere. So 4 ampere comes from this battery, also the same from the second battery. So here the current taken from the battery is 4 ampere. So let's say the lifetime of batteries in first circuit T1 and T2, as the current passing from the second circuit's battery is more, then it will have a less lifetime. Another similar example, we are going to compare the lifetime of batteries. They are formed from identical batteries and resistors. So the current taken from the battery is equal to V over R. The current in the main circuit is equal to the total voltage V, the total resistance R over 2. So the current is equal to V over R over 2, which is equal to 2V over R. But the half of them, V over R, comes from the first battery and V over R comes from the second battery. So the current taken from the battery is again V over R. Here we have two batteries connected in series, so the total voltage 2V, the total resistance 2R, so the current taken from the main circuit 2V over 2R, which is equal to V over R. So you see that the currents taken from the batteries are the same, so the lifetime of the batteries will also be the same.